Hi, in this video we are going to be looking at two multiple choice questions from a recent physics exam. The subject code is 9702. We're looking at paper 1, March 2019. So question number 1, a wave has a frequency of 5 gigahertz. So let's write frequency 5 gigahertz. That will be 5 times 10 to the power of 9 hertz. Good. Our question, what is the period of the wave? So if we denote the period as t, we can write t as equals to 1 over f. So 1 over f, let's write it in 1 over 5 times 10 to the power of 9. You clean this up, you'll get 2 times 10 to the power of minus 10. And keep an eye on the responses here. We have got picosecond, nanosecond, and microsecond. Yeah? So 10 to the power of minus 10, let's rewrite it as 10 to the power of minus 12 times 10 to the power of 2, using the idea of indices. Minus 12 plus 2 is minus 10. That's what you see in this line. So 2 times 10 squared, 2 times 100 is 200. So I'll have 200 times 10 to the power of minus 12, which is 200 picosecond. Correct response A. Let's move on. Question number 2. At temperatures close to 0 Kelvin, the specific heat capacity C of a particular solid is given by C equals to BT cube. Okay. T is the temperature and B is a constant, characteristic of the solid. The SI unit of specific heat capacity is joule per kilogram per Kelvin. Now, what is the unit of constant B expressed in SI based units? Okay, let's start. We have C equals to BT cube. Therefore, making B the subject, we will have B equals to C over T cube. That's what we have here. And we know the units of C, they've given it to us, joule per kilogram per Kelvin. That's what you see here in the numerator. And temperature, T is the temperature, and temperature is measured in Kelvin. So T cube will be, the units will be Kelvin cube, K cube. Again, the units for C, they've given me joule per kilogram per Kelvin. The units for temperature, the SI unit is Kelvin. So this is T cube, so I can write it as K cube. Now, what we need to do next is we need to take care of this joule part. Joule is the unit of work done. Work done is force times distance. What is force? Mass times acceleration times distance, which will be kilogram meter per second times meter. Again, joule is the unit for work, and work done is force times distance. Force is mass times acceleration, ma, and this is your distance d. M is measured in kilogram, A, acceleration, is measured in meter per second squared, and D is measured in meter. That's what I've written here. I've substituted kilogram meter per second squared times meter for joule. And then I have a per kilogram here, and then I have per Kelvin here, and then I have K cube at the bottom. Now this kilogram and this per kilogram will cancel, and I'm left with, in the numerator, I have meter second squared, meter per second squared times meter, and then I have a K to the power of minus 1 over K to the power of 3, and you clean this up, you'll get meter squared per second squared, K to the power of minus 4, and your correct response is B.